Hi, my name is Esther Molnár. I'm a postgraduate researcher at Lancaster University, and I'm going to present our work on economic interdependence of industries. Economic input-output models include all monetary transactions between industry sectors. They identify what goods and services as output are consumed by other industries as input. These mathematical models can be transformed into production networks. Our study's aim is to examine how sectors support each other in growth by modeling production networks developed from input-output models. The study's research questions include whether the production networks have a defined topology, whether it changes in time, and which top industries stay the same. For data sources, we use the newest US input-output account data from 2007 and 2012. We develop and explore the detail-level network of 400 sectors. We examine their topology and centrality metrics under various thresholds for what represents a supporting link between two industries. We find that the production network is highly sensitive to a defined threshold and that the field of sectors is asymmetric. Here you can see the production network at a threshold of 0.1. The threshold is associated with the value of the links, representing inter-industry trade in monetary expression. For example, an edge cutoff threshold value of 0.2 means that an industry represented by node A gets a directed edge to another B if at least $0.2 value is required by industry A to produce $1 of the B industry's output. We define 100 thresholds with equal intervals and cut the graph. Then we generate a scale-free and random graph with the same parameters as our production network at each cutoff point. With the help of the Kolmogorov-Smirnov test, we compare the two distributions at each threshold. We find that the production network topology is highly sensitive to the threshold value, and the out-degree network goes through a scale-free random topology shift as we increase the cutoff point. The in-degree network has a topology more similar to a random network than that of a scale-free network, regardless of its edge cutoff threshold. We also find an asymmetry in topology from the in-degree and out-degree dimensions. It is noticeable when considering the weights of the links and when comparing the two distributions at cutoff points without taking into account the scale of the transactions. When analyzing the top industries according to weighted out degree and centrality at each threshold value, we find that the top three industries tend to remain the same. Although there are big falls, some industries support others with minor value transactions, and the threshold change cuts these off. Therefore, we can conclude that threshold matters quite much at node level too. Most research in production networks looks at aggregate level data. We argue that the aggregate level doesn't give the most relevant picture. Some aggregate categories have only one subcategory in the top lists, such as mining or management of companies and enterprises, while others have multiple, for example, non-durable goods or wholesale trade. This distorts the analysis of production networks. On the other hand, industries grouped in categories are quite arbitrary. Therefore, it can be questionable when analyzing super-industries. Here we show top industries at detail level and sector level according to weighted out degree, representing how big an industry is in monetary terms in the production network, and according to PageRank centrality, representing how key an industry is in terms of location in the network.